Welcome back, guys, to our DSA challenge series. This is the phase 5 of our series, and the questions that we are tackling in this series are based on Q data structure. So let us see our today's question. The today's question says longest continuous subarray with absolute difference less than or equal to limit. We are given an array of integers, nums, and an integer limit. We need to return the size of the longest non-empty subarray such that the absolute difference between any two elements of this subarray is lesser than or equal to limit. We are provided the variable limit in the question itself. So let us understand this question with the help of an example. We were given an array nums 8, 2, 4, 7, and the value of limit which was given to us was equal to 4. So we need to return the length of the longest subarray such that the absolute difference between the elements should not exceed the limit, such that the absolute difference between any two elements of this subarray is lesser than or equal to the limit. So let us see this example. 8247 were the elements provided to us, and the limit value was given to us as 4. So the subarrays possible are 8, 82, 824, 8247, 224, 247, 447, and 7. These were the possible subarrays. In these subarrays, the length of the longest subarray that we can get such that the difference between the any two elements is lesser than or equal to 4, which is the limit, can be 2. So the size of the longest subarray is 2. So how can we, what is the approach for this particular question? So let us understand this approach. I hope the question is clear to you all. So what we are going to do? Suppose if we were given the array as 10, 1, 2, 4, 7, 2. So what we are going to do is, we are going to use the two-pointer approach. We are going to start from the index at the 0th position. At the 0th index, the element is 10. So our maximum element will also be 10 at that particular point, and the minimum element is also going to be 10. In every subarray, we will be checking the maximum element and the minimum element, and we will be calculating their absolute difference. If their absolute difference satisfies the condition of the limit, it means that particular subarray is possible. Otherwise, we need to make the changes in that particular subarray. So we have taken the example as 10, 1, 2, 4, 7, 2 as it was the array provided to us, and the limit given to us is 5. So what we will do? We will start from the 0th index at the 10. At this index, the maximum element is 10 as well as the minimum element is 10. So, and the difference between 10 and 10 is 0. 0 is lesser than or equal to 5. It means it satisfies the condition. Then we will go to the next element, which is 1. Now our maximum element will become 10 and our minimum element is going to become 1. Maximum element will become 10 and the minimum element will become 1. The difference between max and min is what? 10 minus 1, which is equal to 9. The limit allows us is 5. So 9 is greater than 5. It means this is not satisfying the condition. So what we will do, we will remove 10 from our array. When we will remove 10 from our array, the maximum element will also be 1 and the minimum element will also be 1. And the difference between 1 and 1 is 0. It means it is satisfying the condition. And the length of maximum possible subarray till now is 1 because the subarray contains only one element, that is 1. So in our answer variable, we will store 1. Now we will go to the next element, which is 2. Now the maximum element will become 2 and the minimum element will become 1. The difference between 2 and 1 is what? It is equal to 1 only, which is satisfying the condition 1 is lesser than or equal to 5. Then we will go to the next element, which is 4. Now the maximum element is 4 and the minimum element is 1. The difference between 4 and 1 is 3, which is lesser than or equal to 5. It is also satisfying the condition and the length of our subarray is 3 now. Then we'll go to the next element, which is 7. Maximum element is 7, minimum is 1. 7 minus 1 is 6. 6 is greater than 5. It is not satisfying this particular condition. So what we need to do is we need to eliminate the elements. So we will remove the element number 1. Now the subarray contains 2, 4, and 7. Maximum element is 7, minimum is 1. 7 minus 2 is 5. 5 is lesser than or equal to 5. So it is permissible. So we can include this particular condition. So 2, 4, 7, the length of the subarray is 3. So we will keep it 3. After that, the next element is 2. Now 2, 4, 7, 2. The maximum element is 7 and the minimum element is 2. The difference between 7 and 2 is what? 5. 5 is permissible in this condition, and the length of our longest subarray will become 1, 2, 3, 4. So we will return 4 as our answer. So I hope the approach is very much clear to you all. We are traversing through the array. We are storing the maximum element. We are storing the minimum element. We are calculating the difference of the maximum and the minimum element. If the difference is lesser than or equal to limit, we are moving to the next index. If it is greater than limit, then we are deleting the element from our subarray. This is the condition. Now the question arises, how we will keep the track of this maximum and the minimum? For keeping the track of this maximum and the minimum, we are going to use a DQ, doubly ended queue, in which the insertion and the deletion is done in the big O of 1 time complexity. So now let us understand this with the help of a code, the way we have used the DQ. See, in the code, in line number 5, we have initialized a variable ans, which is equals to 0. This variable ans denotes the length of the longest subarray, which we will return as an answer. After that, we have made two DQs as minq and maxq. The front element of minq will give us the minimum element of that particular subarray. The front element of the maxq will give us the maximum element of that particular subarray. We have also made two variables s and e. After that, we have applied one loop while e is less than nums.size. This condition is applied, this loop is applied for traversing through the entire array. So for that, we have applied this condition. After that, we have taken the int x is equals to nums at the index of y, e, that particular element. After that, we have applied one condition while minq is not empty and nums at the index of minq dot back is greater than or equal to x. This condition is applied in order to store the minimum element of that particular subarray at the front of the queue. So if this condition is true, we will going to pop back, and after that we are going to insert push back the e. In the similar way, we have defined the max queue. After that, for getting the minimum element, what we have done, int mini is equals to nums at the index of minq.front. Minq.front will give us the index at which the minimum element is stored, and nums at the index will give us the minimum element. In the similar way, we can calculate the maximum element also. After that, we are checking if our difference, that is the maximum minus minimum, is greater than limit. If it is greater than limit, then we need to eliminate the elements from the array. If it is lesser than or equal to limit, the condition is satisfied. We just need to increment the value of ans and e. So if the difference is greater than limit, it means we need to eliminate the elements. So for that, we have applied these conditions. Otherwise, what we are going to do, we are going to check the value of ans equal to max ans comma e minus s plus 1. E minus s plus 1 denotes the length of that particular subarray. After that, we will increment the value of e. In this way, once the loop get completed, we will be able to get the length of the longest subarray such that the difference between any two elements is lesser than or equal to limit. I hope the question is clear to you all. If it is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.